Okay, so can you give like a brief 1-minute overview about yourself? Maybe like where you go to college, I guess, since you're like anonymous anyway. Like how much LeetCode have you done? What you're interviewing for, stuff like that.
Uh, yeah, sure. So I'm a first year at Georgia Tech. I'm probably like interviewing for typical software engineering or data science intern roles. Um, yeah.
Okay, cool. Yeah, actually, I was looking into like their master's program. Apparently, 1 billion people do that stuff. So
Yeah, there's an online master's program and it's pretty popular. Yeah.
yeah. So probably gonna apply to that. Okay, cool. So let's get started. So the first question is this. So you're given a string, for example. Let's say a string is like ABA. And I want you to tell me if it is a palindrome after removing at most 2 letters from it. So you don't have to remove anything. So in this case, it's just already yes.
hmm
And then if I have a string like, let's see, like ABCA, this would be yes as well because I can remove the B or the C, and that would make it a palindrome. But if I have a string like ABCD, then this would be no because no matter what 2 I remove at most, it can't be a palindrome. Yeah, so feel free to ask me anything you need to. And then we're gonna go until 2:25, which is 50 minutes. So just keep track of your time, and there's gonna be 2 questions.
Okay, cool. Um, that sounds good. So, are there any restrictions on the length of the string? Like, can it be an empty string?
So it can be an empty string, but let's just say for simplicity, it can only have lowercase English characters. So
Okay.
so an empty string would be a palindrome. But yeah.
Okay. Yeah, that makes sense. Um, it's a palindrome. Okay. And then basically we want to know if this string can be a palindrome after removing anywhere between like 0, 1, or 2 letters.
Yes.
Okay. Hmm. So here, that's obviously a palindrome. Here, let's see. Okay, so this could not be a palindrome because, for example, the 2 letters at the end are already different. And then say you, well, let me think. So say you have like A, B, C, D, and then you could have like a pointer here, and then also one at the end for D. Um, so if we compare the two, then they're obviously different. So we can try like advancing one. So then maybe we compare B and D. And then at that point, it's still different. So we need to change again. But then at that point, we would be out of, I guess, like shift. So then this could either move in or maybe that one could stay. And then the left pointer could shift over. Um, and I think that would let us determine whether it's a palindrome within some number of shifts. Okay, so I guess like the way I'm describing it, I'm not sure if that makes any sense at all. So we can have essentially like 2 pointers at either end.
Mm-hmm.
And then if the two are the same, then that's great. Then we can like move both of them inward by 1.
Mm-hmm.
So then, but if they're different, then we essentially have to shift we have to choose one and then shift it. And then we can do this at most 2 times max.
Mm-hmm.
Um, okay, so then the question comes of like, how do we know which one to shift? Um, Okay, so I think we can take like a, well, since there's only two, we can probably try shifting either one, and then I think we can take a greedy approach where after the shift we can see if like either one actually like matches and results in like being the same letter. So I guess what I'm imagining is for like the ABCA scenario, we have left, we have like left and right pointers at 0 and like 3 originally. And then since the first one is a match, we can have like left becoming 1 and right becoming 2. So then it would be at B and C. And then since that's not a match, we can try advancing like the left one, say. And then so left becomes 2, right becomes 2. At that point, it matches. And I mean, they kind of meet at the center. So then we know that it's a palindrome.
But what if they didn't? Like you try it and it doesn't work. How do you try all the different ways? Yeah, and you can have two removals, right? So you can have like removals in different places. Yeah, how do you handle that? I guess how do you, like a generic case.
That's true. So maybe I'll try coming up with something like this, maybe. This
Okay.
work. So then essentially B and C. Oh, that's true, yeah. Or like how would you know which one to move?
Like it's fine to be able to try both, but you need to be able to like come back, like if it didn't work, and say, "Hey, I tried this one. Now let me try other stuff." You know, you can't just like pick one and go to the end, and if it failed, then return false or something, because you need to be able to try like all the possibilities.
That's true. Um, so how, okay, so if we were to try that, then so maybe we can track the uh the index of like whenever there's a mismatch, we can track hmm, okay, so maybe so there's like so we can track the index on a mismatch for both.
Okay.
And then okay. And then say we try shifting one of them, and then at the end we find that it doesn't work. Could we just, since at most we can remove like 2 letters, I think that translates to tracking uh like 4 indices, right? Or like 4 different possibilities to try, which doesn't sound too bad. So
Okay.
um so I guess like could we just try all 4 ways and like just like do like the normal palindrome check, like moving inward? Um
Yeah, I mean, if that works for you, it seems reasonable. And
okay.
what would be the time and space complexity of that?
I think it's just O of n because we have like 2 pointers moving inward. Then at most you can, I don't know, go through the whole word like 4 times. So yeah, I think that would be like O of n's time and O of 1 space.
Okay. Yeah. Yeah. So if you want to think about anything else, you can. If you want to code it, you can as well. Whatever you prefer.
Okay, cool. If everything sounds good, then I'll probably just code it then. Yeah.
Okay.
Yeah. Okay. And so we just have a string. We can do a basic check for if the string is empty, then it's just true, trivially. And then we can initialize the left and right pointers. Then we also need to track the places where there's a mismatch. See, so maybe we use, let's see, maybe just an array for now. So yeah. Okay, and then as we go through the string, I think there's like 2 cases. Like the first is if they match, then we can just both advance both of the pointers like inward by 1. So if they match, then left increments and right goes inward by 1. Let's see, and then if it doesn't match, then we need to know how many letters we've skipped so far. So maybe we have to have a counter for how many letters that we've skipped.
Okay.
Okay, so then otherwise, okay, so let's consider the case where we can basically skip this letter. So then if the number of letters that we've skipped is less than 2, then at this point, we basically need to pick one of the pointers to change. Okay, so okay, so what does that mean? So if we pick one of the pointers to shift, then okay, maybe this needs to be like a tuple. So then the left and right pointers that we go back to can get like coupled together. And so then we would track the current left and right.
Okay.
Let's see, and then we would want to just like, I think we just stick with incrementing the left one. That way when we go, if we ever go back to the option, then we know to try moving the right one instead of the left one.
Okay.
Does that seem okay?
So you're basically saying like as a default, you will try the left, and if it fails, you'll try the right.
Yeah, like basically when we add this pair to the option, we basically just advance the left one. And
Mhm.
then if we eventually find out that that doesn't work and there's like options left, then when we come back to the option, like maybe we would just like pop this off of the end,
Mhm.
and then we would try, we would always like change the right pointer when we go back.
Okay. Yeah, makes sense.
Okay. Yeah, so if we can still skip, then we do that. We increment it. And then I think that's fine. And then if we get to the point where we see, okay, we already used both of the skips.
Mhm.
Then there's two scenarios. If we have like no more like options left, or like we already tried like backtracking, I guess, to this like previous point, and then we like we used up all of those, um then we just want to like return false, because then there's no way that we can get a palindrome.
Okay.
Um Otherwise, uh I think we can take the left and right and then just decrement the right one.
Okay.
Um, Let me see. Okay, otherwise, skipped. I think I'm forgetting something. So once we pop this, then, oh, we would have to, uh, oh yeah, we have to track the number that we skipped. So each time after we append it, then we have to like increment the number
Mhm.
that we've skipped. Um, Otherwise, we need to decrement it, because well, no, do we? Okay, let me think. No, we have to skip one either way. So regardless of whether we shift the left or right, we have to shift one. And so skipped should never be, uh, it should never be decreasing, right? Um, hmm. Unless we have the case where we basically, say we like shift the left pointer twice, then we, uh, okay, and then say that after doing that, it didn't work out.
Mhm.
Then we would go back to the latest time. So we've still shifted the left pointer once, but then the second time we shift the right pointer. Okay, so then say that that still didn't work out, then options would still be length one. Um, we would look at that option again, change the right pointer. Um, okay. Oh, but then at that point, if you go back, um, sorry, I think I'm like confusing myself a little bit here. Okay, so maybe I'll just try walking through an example. Yeah.
Sure.
Okay. What's a string that would not work out? So like
A, B, C, D is like the easiest, or just 4 different letters?
yeah, I think so. And maybe make it like a little bit longer.
Okay.
Okay, so I guess like tracing through this.
So actually, this would succeed.
Oh shoot. Um uh okay. I think this should be fine, right? Okay, so we start left equals 0, right is at like 2, 3, 4, 5. Right is at 5. Then there's a mismatch. So then left goes to 1. And then at this point, options would be like 0, 5.
Mm-hmm.
Okay. And then left would be here. So B doesn't match again. Then we shift it again. Then at this point would have 1, 5 here.
Mm-hmm.
C obviously also doesn't match D. Okay, so then at this point we would pop from the back of options, and then we go back to 1, 5. And then we change this to 4. So then we have 1, 4, which doesn't match. Okay, and then at this point, we've skipped 2. Wait, maybe wait, no, skipped is just the, I think it's just the length of, oh no, it's not. Okay. Okay, well this is
Okay, just to give you a hint that might make things
okay.
a lot easier for you, is what if you made this recursive?
Recursive.
Yes. So you just keep track of your skips and your indices in a recursive call.
Okay.
Because I think that
So
what you have might work, but I also do see the problems with it where, yeah, like if you pop both your options and you go right, you should only have 1 skip, but you'll have 2.
yeah. Okay. So for recursion, okay, let me think about what states we need to track for recursion. Okay, so basically we have the current left, right. We have S, and then we also have the number of skips that we've used so far. And then essentially, okay, if we outline the recursive algorithm, the base case is if left is like if like left is greater than right, then that means that we that means we found a palindrome, I think. Okay. And then if like if skipped is greater than 2, that means that we like need to return immediately. Like we can't really continue. That's not valid. Okay. Okay. So then thinking about like the recursive calls. Okay. So then if they match, then we just call it again, but with left and right incremented. If they don't match, then
So if they match, would you need to call it again with left and right incremented? Because if you do it that way, you will, like, imagine your string is long, you will have this recursive stack, and then that's not O of n time, right?
oh, that's true. Yeah.
So you basically said, like, because I only have 4 spots to check, I have O of n space. So can we keep it that way?
Yes, yeah. We can probably just do like a while loop or something. Okay. And then okay, so essentially a while match, adjust both pointers. Yeah, and then if there's not a match, then we can just split into like 2 recursive calls. We can try incrementing left, and we can also try incrementing right, or like decrementing right. And then yeah, so like split off in 2 recursive calls if not a match. And then I think in like all of this, we can just like have this like we can OR the result with this like variable that we like keep track of, which is like the final result, so that if any of the recursive calls end up working.
So I see. So you can try everything and then you'll just OR the result. So is there something you can do that's better than that?
Or I think maybe at the beginning we can also check that variable. So like we can check like if the result is like true, then we can just like also stop right there.
Yeah, because as long as any recursive call succeeds, we don't have to check the rest. Yeah.
Yeah. Okay. Okay. I think that clears it up a lot more. Then yeah, that makes sense.
Okay. So do you want to change it to that?
Yeah. I can make a copy of this down here, and then I'll just adjust it. Okay. So I can basically have this recursive call. We can like define like a recursive like a helper. And then we'll have the string, or I mean, I guess we have that context already. So we have left, right, and then the number of skips. And this should return. Should this return? I think we can just set like yeah, I don't think this needs to return anything.
Well, don't you need to know if your recursive call worked? Like you try moving some stuff. Don't you need to know if that was a palindrome or not?
Yes, I think we can just change this variable, but yeah, we can also return it. That works. Yeah.
Okay.
Okay. So this. Okay. Essentially, we have if, okay, yeah, so if left is greater than right, we return true. We want to check if we want to check before that if skipped is greater than 2, then we want to return false. Okay, so we did that, Okay, and then we want to say while they're equal, we do that. And then and then here is where we split off into 2 recursive calls. So we want to return whether that's right or +1. Okay. I think that's fine, because if any one of them is true, then it short circuits and returns immediately. Okay. Or we can just call this from here.
Okay. Yeah, I guess
Okay.
you can try it on an example.
Okay, sure. I'll try it on I'll try it on ABA and then ABCD. Okay. So for ABA, we would go skipped is less than 2, left is less than right. Okay, and then we would go into this while loop, and then left and right become 1 and 1. And then again, it's the same. So then we continue, left is like greater than right, and then we return this. Left is greater than right. So then it returns true. I think that works. And then if we try ABCD, then we split off into a recursive call where left is 1, right is 3, then skipped is 1. And then we have this case. So then we have these 2 cases. And then each one splits off again. So then, because none of the letters match, so then you have basically 2, 3, 2. And there's like 1, 2, 1, or sorry, 2. And then this splits off into 1, 2, 1, then 0, 1, 2. Oh, sorry, these are 2. And then again, I think none of them match. So then skipped gets incremented again in the next branch, like split, and then this check triggers, and each of them should return false. So then, since all of them return false, the final result should be false. Yeah.
Okay. Yeah, you can try running it.
Oh, yeah, that's true. I forgot that that was a thing.
Let's comment out this first one. Okay,
Yeah.
go ahead.
Okay. Oh, that's right. There's another definition, and then that's false, and that's. Oh shoot. Yeah, that's kind of a rookie mistake there. Okay, I think. Okay, I believe this should fix it.
Okay.
I believe this would fix it. Unless. Okay, and then we need to add a check here. Actually, we should move this down because if left exceeds right, and then skipped happens to be 2, and then skip increments again, that would cause it to be incorrectly false. So I think this check should be down here.
Okay.
And that should work.
Okay. Yeah, I think
Okay.
this is fine. You could have also just so like once you get here, this is always true. Actually, no, not necessarily. No, never mind. Okay, no, I think this is good. Okay, let's move on. So we have about 15 minutes for the second one, so just want to get as much as we can.
Okay, yeah.
Okay, so for the second one, you have a string s again. Let's say it's like this. And you have an array of words. So for example, let's say of code. And basically what I want to know is, given my word bank, and I'm able to reuse my words, can I break my string into a sequence of these words? So in this case, you would be able to, because you could just do this. Also, if the example was, this also works because you can reuse. But then if it was like leetcode leets or something, then this would not work because there's no way to get it perfectly broken down. Does that make sense?
Yes. Okay. Oh boy. Okay, so let me think about how this would work. So I think. Okay, so that means that for each letter. Okay, so like, okay, so we have this whole word and then we have the array of words, but we don't necessarily know where is like the best place to break this word.
Yeah, because you could have had like this as well, and if you break like that, then you wouldn't get a solution, right? Like if you do this.
Yes. Okay. Okay, so I think we just need to try this like one letter at a time. So like what I'm imagining is like, okay, so you could like convert each word into like an iterator, and then like iterate through like one letter at a time. So like for example, for the first one, like L would match with Li and Leet, E would match with the second letter of both, and then the third E would like um Oh yeah, and I think since they can be reused, like the iterator has to be like reset once it reaches like the end of each word. Um
So you're basically saying like, I'm gonna go through here, and I'm also gonna have an iterator through all of these words at the same time. And I'm
yes.
gonna move it down, and wherever there's like a valid thing, then I'll like do something. So basically, like I'll move this, and I'll also move these at the same time, like so on.
Let's see.
But
So
also for
I
like,
think we
oh yeah, go
only
ahead.
move is if there's like a match. Yeah.
Yes.
And then whenever there's a mismatch, I think we have to reset that word's iterator back to the beginning. Wait. So if there's a mismatch, um, and then and then if we do that for all of the words, then we know that like it's impossible to split S up into each of these words.
Yes, but you'd also have to like for example, it matches with Lee, and then it also matches with Leet. So you'd be like done with one iterator, and then you'd be like in the middle of another one, and so on. So I think this approach probably works, at least somewhat, but it's a little bit
okay.
complicated. So how
Okay,
can we
yeah.
do something simpler
Okay.
instead of having all these running iterators?
Hmm. Um, okay. Let's see. So we can't really keep track of the numbers of letters because it needs to be in the right order. So like
Mm-hmm.
I don't think any kind of hash map works here.
Mm-hmm.
Um, let's see. Uh, let's see. Um, this also doesn't seem like uh this doesn't seem like DP because you don't really know how to break it up.
Okay, so let me ask you
Um,
this.
okay, yeah.
If I knew that this entire chunk was not being able to be broken up, right? If I knew, like, okay, if I start here and this is not possible, okay?
Yes.
Then when let's say there's a word Lee in here, and I'm like, okay, so I'm going to try Lee, and now I come here, and now I know this is not possible. You can get to the same place in many different ways. Like, for example, let's say we have this. So I can get to code either using Lee and ET or Leet, right?
Mm-hmm.
And then if I knew this from one of these iterations, like if I knew that actually from code this wasn't possible, then the next time I get to it from the other one, I can be like, oh, I was already here, and I already know this is not possible. So therefore, I don't need to like recompute that whole thing. So how would you do that?
Um, okay, so could you explain that last part again? You mean like, okay, so we've already like gone through code, for example, and like we know that this doesn't
Yeah. So let's change this
wait.
example to this, okay?
Mm-hmm.
So let's say we're gonna say, oh look, for this Lee, we can break it into Lee, and now from this ET code, we have an ET. So now we're here, right?
Mm-hmm.
And we say, well, there is no code, there's nothing. Like, okay, maybe we'll try co, and then we know like this is not possible, and this is not possible. So we could say like from here, this is not possible. From here, this is not possible. Does that make sense?
So I'm a little bit confused. Wait, so if we started from the beginning,
Mm-hmm.
we wouldn't know that like code is not possible until we
Right.
got to
So
it.
we wouldn't know. Yes, we wouldn't know that. So when we start from the beginning and we try Lee and then ET and then CO, we realize that DE is not possible and code is not possible, right? Like when we tried this combination, Lee and then ET and then CO. So then when we try leet, we're going to jump to code again, right?
Oh, I see.
And we're going to be like, well, do we need to recompute this again? No, because we already had it.
Oh, okay. Okay. Let me see. So how, okay, so how would you track? Okay, so we're basically tracking at each like index whether, wait, no. So okay, so you're saying like for a single word we need to mark like the index of where it's a match and where it's not, or
So not quite. So let's say I have a function
okay.
that's like can split, right?
Okay.
And it takes an index.
Okay.
If I ever get here again, I'm doing the same thing, right? So like if this says no for index 5, then when I get here again, I should say like, well, I already been here, so I already know this is no. And then basically the idea is like, I mean, there's a few ways to do it, but one thing, let's say, is like I can just start somewhere and I can just keep incrementing a string, and every time my string slice is like in the words, I can try to recurse. So for example, going back, I could be like, well, is L in words? No. Is LE in words? No. Or LE is. So then I'll like recurse to this part and see if it's,
I
you know.
see.
But you still want to like avoid doing repeated, like, so yeah, basically, you know, this can split function, you want to avoid computing it over and over and over on the same index. So once you have a value, you can just like auto return. Does that make sense?
Yes, that makes sense. Yes.
Okay. So what would this look like then?
Okay. So okay, so if we started from the beginning, okay, wait, so we would have L, and then we would see like, okay, L matches like the one of the words, or maybe like
So
there's no match at all. But
you don't
okay,
need to check character by character. You can just match the whole word. So you can
okay,
just say
yeah. So
like, is
this is
L
not
in
in.
words? Yeah.
Okay, okay. So that's not in words.
Yeah.
And we check if LE is in words.
Mm-hmm.
If LE is in words, then we can. Okay, and then would this split up into like two recursive calls? Like we would check whether LEE is in words, and then whether like E is in words.
No, your recursive call would be, if you split it on Lee, you would recursive call on at code. So you would say like, this is whatever this is. If this is true, then this is true. And if it's false, then I'll keep going. Then I'll try like Lee, and then I'll try leet, and so on. And I have to get a recursive call somewhere. Kind of similar to the is palindrome thing, except here we only had two things. Imagine if it was like we can take out infinite, infinite put things. So that would be, that's what that would look like. So basically you could say like, for Lee, is this possible? If yes, then we know we just made a split, so that was valid. For leet, is this possible? If yes, then it was possible, and so on. Does that make sense?
So how do we know? Why are we able to split it at like L? So after we split it at LE, like how do you get back to splitting at like LEET? Because I thought like at that point we weren't really looking at like the first two letters of S anymore. Or
So it's kind of the same thing as the palindrome thing once again, right? You're like, I'm gonna make a recursive call here. So like here I'm gonna recurse. And if this fails, then I know this path down splitting at LE doesn't work, right?
oh, okay.
And then I could recurse here again. and then I could say if this fails, then I know splitting at LEET doesn't work. And basically, if I go through the whole string and I was not able to split it anywhere, then like
I see. Okay. Okay, I think I understand. I probably like overcomplicated it.
okay, yeah.
Okay, so I don't know how we're doing on time. Like, should I try to like code this out or
I think we can actually just stop because we're at
okay.
exactly the time, and I think it would take you like quite a bit. So let's
Okay.
just do feedback instead. I think I got some very good information. So what are your thoughts first of all? Like what do you think you
Okay.
did well? What do you think you need to improve in?
Yes. So I think I did fine on like trying to understand the problem, I guess like communicating my ideas. I think like I
Mhm.
tried to continuously talk, which is like not something I'm very used to doing when I'm thinking about a problem. But
Mhm.
yeah, so probably just like um talking through the cases and like maybe my thoughts. I think I got kind of hooked on like speed of problem solving. I
Mhm.
think I was like too slow and I'm not sure. Like uh maybe on a real interview, like I would have uh I don't know, maybe like asked to uh I don't know actually. Yeah, I don't really know. But I think like definitely just like more practice. Yeah,
Okay. Yeah. So I
yeah, I'm
think
not sure.
I think you
Yeah.
ran into. So there's a couple things, and I'll point them out. So in the
Okay.
first problem, you did kind of figure out like you figured out a high level approach. You were like, okay, so I'm gonna have two pointers. I'm gonna have two max shifts. I'm gonna keep track of all my shifts. And then you started coding. And I think this is a very common mistake where you come up with a function, you don't really know how hard it is to do. You're just like, I'll just do something. This looks good. Okay, let me start coding, and then I'll figure it out. And then once you started coding, like my thought was like, it's probably doable, but it's probably complicated, and you might get completely stuck and like not know how to do it because you didn't really talk about any like how am I going to implement this at all. You're right. You were just like, I'll just have four locations and then it'll be somewhere, and then like we'll see how it goes. Um,
Okay.
so I would definitely spend a little bit more time going a little bit lower level on like the trickiest part of this algorithm is like this options thing, right? That you had. So I
Yeah.
would try to figure that out before you start coding and be like, is this even viable? Like, and the other thing is you want to figure out like what are multiple approaches. So this option thing is kind of like a stack, I guess. But you could do a stack or you could do recursive. And so
Mm-hmm.
I feel like if you would have realized like, oh hey, I can do a stack and I can do recursive, what's easier? Because like when I told you to do recursive in like 5 minutes, you kind of had the idea and like it like worked, right? So
Yeah.
you should definitely like evaluate is what is doable, and like it can't just work. You need to be able to actually write it. So if one's significantly harder and they're both the same like time complexity and stuff, then like pick the better one.
Okay. Yes.
And I feel like if you would have recognized that, like, or if I would have said like, hey, maybe this is doable, but I'd like you to go in this way, you would have done better. But unfortunately, like, most people aren't going to do that.
Mm-hmm.
So
That makes sense.
so
Yeah.
definitely plan a little bit out, like a little bit more lower level, and be like, am I even going to be able to code this, or is this just way too complicated? I'm just going in the wrong idea. And it would save you a lot of time because if you're like, okay, this is how my options are going to work exactly, and if you realize after 5-10 minutes like, okay, this is just not working, let me try something else, then because basically what you had to do was like you wrote all your code and it was like, can we do this, and you basically deleted your code, right? uh
Uh-huh.
so so yeah, I would definitely recommend in this higher up part, plan out what you're going to do, and then the coding should be like, I know pretty well what I'm going to do, and now I just need to write the code and I don't need to think about the entire algorithm in my code. Does that make sense?
Okay. So okay, so but like for the actual like lower level like details of the function,
Mm-hmm.
it's kind of a lot to keep track of in my head. I think like at least for me. So would you recommend like just writing pseudocode in
Yes.
this like doc
Yes.
string and
Yes. So I would,
okay.
because I think I noticed that too. You're like, okay, so I have this like one option, and then I add another option, and then I pop, is my skip thing correct? Like, you were kind of trying to see it in your head for like 5 minutes. So I would try to do that. I'd be like, okay, let's say I have 2 places I can pop. Like, I'll have this option, you know, and it will like add in like L1 R1, and that will give it a skip. And then maybe I'll do like an L2 R2. Now, what happens when I pop, right? So what happens when I pop this one? Write some stuff, and then the other problem is you were like, well, does my skip ever decrement? It definitely does, because if you pop both of these and you go right, now your skip is
Yes.
1. So if you would have
Yeah.
if you would have written this like small thing and have a better idea of how your function works, then maybe then you'd be able, because I'm sure this is doable with a stack as well, just more complicated. So
Yeah.
so once you understand how that works very well, then I feel like the rest, like the code is easy. You know, like if you know how the options popping and like keeping track of the skip amount and going left and right works, like the rest of it is very easy. Do you agree?
Yeah. So I think like a really important part is like the complexity between the two approaches is like pretty different, like depending on which path you decide to go down. So like how would you recommend or I guess like build up this intuition in your head of like, oh, this approach might be over complicating things and like I should just like try some other ideas
Yeah.
instead of
So a really simple solution there is like, let's say you're doing a tree problem. And so a tree problem, most of DFSs you can do with a stack or recursive. But if you do enough, you just realize like recursive is actually like very easy to write compared to a stack. So this kind of thing, you'd say like, okay, so I can have this option thing, or I can have recursion. Which one is going to be easier for me? And you do that by just doing enough problems, and you need to figure out like what's actually possible. So I think that's where most people trip up on this problem, is they try to do something like you did, and they either have this options, or they're like, okay, I'll add one to my skip, and now I'll have this like inner while loop that does the same thing, and now I have this like nested same thing over and over and over. What the hell is even going on? I think with one removal, it's a little bit more doable because there's like less states. But with 2 or 3, you know, what if I said like there's 3 or 4, then it gets really out of hand. Well, with recursion, it's like very easy. All you have to do is keep track of your skips, and then you just do the same thing over and over and over. So you can think about it that way. You basically have like, this is like kind of like a DP or a tree problem, and then it's like you could do either one, but what's going to be easier? And in my opinion, I think here recursion's a lot easier. So I think you need to have like enough tools to recognize like what's good, and then from there figure out like, okay, what can actually write and like write well and stuff. And then basically if you were to realize like, oh, recursion way easier, then you can code this in like 5 minutes. And then let's see. Yeah, so I think that's the big takeaway from problem 1, is you had a high level overview, but you didn't really plan, is any of this actually doable or how hard?
I see.
And you really don't want to get into that spot, because you might spend 15 minutes thinking of an approach only to realize it's impossible or very difficult.
Yeah.
And then that's like an auto fail because you just like run out of time.
Yeah. Okay, I see.
Okay, and then for the second one, once again, you did the same thing so you did spend a little bit more time trying to figure out how this works, but you like massively complicated your solution, where you're like, okay, I'm gonna have these like running iterators everywhere. I'll go one letter at a time. I'll probably have to like get rid of words that like don't match the iterator, because like if this is an L and some of my iterators have a C, I have to like drop those iterators. And then like I have to keep track of like where the iterators end. So it's like the two simple solutions that are like reasonable is A, for every word in words, just compare to S, right? So then that would actually be the same time as an iterator, I think. So you could basically say like, okay, I have leetcode. I'll just compare to leet. Does it match? Yes. Okay, then I'll just cut here. And then I'll do the same thing with like code here. So that's one simple one. The better one is a set, where you just do one letter at a time, and then you just check if it's in words. The best one is a try, but like for an intern or anything, I'm not expecting any of that, because a try will literally let you go down the letters and it will tell you, is it in words in constant time. But I think you did say like, I don't think it's a DP problem. So I was like, okay, I probably have to give you some hints to realize that it is a DP problem, because you're essentially cutting at every point, and then you're just recursively calling like, now can I do this? Now can I do this? Over and over and over. Does that make sense?
Okay. Okay, yeah, that makes sense. Yeah.
So my thing is like I think you don't have enough tools to use, and it takes you a very long time to figure out an approach that is overcomplicated a lot. I mean, the nice thing is like you're a freshman, so I don't know if you apply to like a freshman intern. I don't even know how any of that stuff works, but like I think for June, like yeah, I think for like
Yeah.
big tech, like this question is pretty reasonable even for an intern.
Yeah.
So
I see. Yeah.
yeah.
So probably like more practice. Yeah. Like I think like a lot of interviews so far that I've come across, a lot of them are like kind of behavioral, or like they'll just ask you to talk about projects and stuff. But yeah.
Mhm. Yeah, so I don't know how like freshman interviews work or what the bar is and stuff, but like I would imagine basically like a
No, this is definitely reasonable.
okay.
I think like yeah, this is a pretty fair problem. Yeah.
Yeah. And so basically for intern, I just try to give more hints and I ask like what would I ask for like a tech screen or something for like a
Hmm.
normal new grad or mid level or whatever. And then I'll do that. I'm
Okay.
not gonna ask anything complicated. I'm not gonna ask any like advanced stuff. But yeah,
Yeah.
like DP or like, you know, anything like easy graph problems or whatever, I think are like fair.
Hmm.
So and I guess the nice thing is because you are in college, like I would imagine as a college student, all you're doing is like studying, preparing for interviews, right? So uh,
Yeah.
you
Not
don't have
really
like
too
a
much
full-time
else.
job that you don't have like a full-time job that like you have to do while you're doing all of this stuff. So as far as the coding stuff, I don't think you should be significantly worse than experienced people as far as DSA anyway, because experienced people don't really do DSA on the job. They have less time than you, and like
Yeah, for
as they get
sure.
higher,
There's not really an excuse. Yeah, exactly.
yeah. But
Yeah.
I mean, you're a freshman, so like as long as you get better at it within the next couple years, like it's
Cool.
fine.
Okay.
And yeah, and then basically I'd say for like, so this would be like what you would get for a competitive company. Obviously, if you get like a startup or some other stuff, things can be really easy, but then there's just like a high variance. So I would just recommend preparing for this kind of stuff. And then if you get it, you can pass. And if you get the startup, you'll pass anyway because you prepared higher than what you needed.
Okay. Yeah. Thank you very much for your time. Yeah.
Yeah, no problem. Okay, cool. See ya.
Okay. All right. See you.